So this video will be about properties of limits. There's 5 important properties that we'll go over here. The first being composite functions. So how to find the limit as a composite function approaches a specific value. So here we have f of x equals 5 minus x. I have g of x equals x cubed. And we want to get the limit as x approaches 1 of g of f of x. And the rule is this is equivalent to g of limit as x approaches that value of f of x. So if we do that real quick, it's equal to g limit as x approaches 1, 5 minus x, which is equal to g of 4, because we do direct substitution. 5 minus x is 5 minus 1, we get 4. And g of 4 is equal to 4 cubed, which is equal to 64. Now, one way you can always check these problems is simply by setting this up as a single function. So you can say, let's say h of x is equal to g f of x is equal to 5 minus x cubed. And if you then take the limit as x approaches 1 of 5 minus x cubed by direct substitution, you get 5 minus 1 cubed, which again is equal to 64. This kind of shows you why the previous rule is true. It's pretty intuitive, makes a lot of sense. So there's another problem here. F of x equal to 4 minus x squared. G of x square root of x plus 1. And again, if we take the limit of g of f of x as x approaches 1. So again, this is equal to the limit, it's equal to the g of the limit as x approaches 1 of f of x, which in this case is 4 minus x squared. And so if we do that, we get g of 4 minus 1 is 3. G of x is equal to the square root of x plus 1. This is equal to the square root of 3 plus 1, which is square root of 4, which is 2. That's as far as composite functions go. As far as the other properties, we'll just do a couple examples here that kind of show it real quick. And so let's say you have some function f of x, and you know that the limit as x approaches c, which is some value, doesn't matter specifically what it is, of that function is equal to a specific number. Let's actually make that 3. And then you have the limit as x approaches c, same value, same x value, as some other function is equal to 2. It doesn't matter what the functions actually are, because we're just going to apply the properties to them. So for the first part of it, do multiplying by a constant. So if you have the limit as x approaches c, again that's the same x value, of 5 times g of x. So over here for a constant, the rule is you can take out the constant. So that's equal to 5 times the limit as x approaches c of g of x. And we already have that before, that was one of the givens. What that limit is, it's 2, as you can see above. So it's equal to 5 times 2, which is equal to 10. So that's the constant multiple rule. You don't have a rule of, let's say you're taking the limit of two functions added together. So again, we got as x approaches c of f of x plus g of x. And again, this is going to be each individual limit plus the other limit. You got limit of f of x as x approaches c plus limit g of x. And we were given those two before, 3 and 2, so it's 3 plus 2 is equal to 5. There's the multiplication rule. So we have the limit as x approaches c of f of x times g of x. It doesn't matter what the actual functions are. Just looking for limits here, and we were given the limit values at c. And so this is going to be equal to limit x approaches c of f of x times limit as x approaches c g of x. And again, we were given those two values, it's 3 and 2, and so that's equal to 6. And for the final one, we have the division rule. And again, this is each individual limit. So we have the limit as x approaches c f of x divided by g of x, which is equal to 3 over 2. So these are basic properties, pretty intuitive, pretty easy to use. That's how they work.